Alright, in this video I'm going to walk you through how to calculate the center of gravity for a multi-directional steam pipe. In this case it's all uniform 6-inch pipe, so I'm just going to use lines because it's uniform. We don't use the actual weight, we can just use the distance as the weight factor, right? So typically if it's all uniform, you don't really need to have the weight per pound, per foot, or per meter. I'm going to go to options here and click into, I'm going to go to angle constraints, and I'm going to just turn on isometric cursor and set as active, and then hit apply. So the sketch that I got is in this direction 4.5 feet, so JD 4.5, enter. And then it's 23'8", so JD 23.66667. I'm just gonna go 67 because this isn't really what I'm not gonna calculate on this one, and it wouldn't matter any with that small amount. And then JD 11.75. All right, and then there's a representation of the pipe. So make that black. So zoom in, we get put some dimensions on it. All right. To get this in 3D, it's going to be, what you need to do is calculate to actually locate the center of gravity. I'm just going to do it in 3D. So let's do this. Hook it up with 3D. So it looks like 3D, don't it? And then I'll go point relative on the x-axis negative 4.5, enter. And then 23. 67, enter, and 11.75, enter. All right, so now that's this. Rotate it in X, and we want to go, 90, enter. I think it's actually like that. And then I'm going to move around. Let's take this and set up our center and orient it so that it's like the picture, right? So now we actually have a 3D representation. So how we get this is we go V, Control K from the center of this one to the center of this one, K, enter. And I'm going to lighten that up. And then once we find the center of gravity of those two along this line, we'll go from that one to that one. So let's do the calculation. Let's put the dimensions in there. Oh, H stuck on. Starting to look like the other one, but it's in 3D. All right. So the halfway point here, we get, so there's the halfway point. So that'll be what you need to calculate the distance. All right, you can use, let's get rid of that. I don't really need it. It is halfway point and halfway point, so you can use the Pythagorean theorem. calculate the diagonal here. All right. So now we have the center of this one, and we have the distance between the two centers. So we're going to go into the calculator, and then we're going to type in the distance 13.21 times the weight of the piece at the end, right? 23.67, 23.67 divided by, and then open the parentheses, the total weight. So we're just going to add it, 11.75 plus 23.67. So there you go. Let me copy that. Control C, compute. Control V equals, and then I'm going to paste that down there so you can see the calculation. All right, and then show you what that is. 13.21 is the distance. So it's actually this weight times 0, which is 0, plus this distance. I mean, this distance times the weight, which is 0, so it becomes 0. So you have 13.21. I think that's what the physics part of it, but in this case, all we got to do is multiply 13.21, the distance, times the weight, the total weight. We only have the half distance here to calculate the diagonal. And then you divide the thing by the total weight, which is the 11.75 and the 23.67, and that's the weight. If it's uniform, you can just use the length. All right. Now we have 8.27 along this line. So V, this is not an isometric drawing, it's an actual 3D, so I can actually just go along this line. Change the distance, use the selection handle, and I can change the distance to 8.8278. 8278. All right, and then that is the center of gravity of these two pieces. All right, let's go. I don't need this to be heavy. Change it to red. That's fine. All right, now that we know the center of those two, then we're going to take, let's turn it to green and go from green there to Control K, enter. So that's along the distance. But now you can see this is in 3D, right? So figuring out the length of that is a little challenging. You got to do that. You got to calculate the height too. You got to calculate the height of the center of gravity of these two, and then use that height in the diagonal of the hypotenuse for a cube. So it's a little more complicated, right? So let's leave it the way it is, and then. But this is how I would do it in the 3D program, just so you get an idea of what it is we're trying to accomplish. So right now, I'm going to go the distance here, since I can just pull it here. It's easy. I don't have to calculate it. I could just pull that distance, and it's 16.04. So then we go up here. We go distance 16.04 times 4.5 divided by open parentheses, and then it's the weight of the whole thing. 11.75 plus 23.67 plus 4.5, close parenthesis. And then hit copy it, Control C, and then hit compute. Control V equals. That gives me the 3D. So this should be red. And we have it. So 1.8081 along that line. So I'll make that green, but heavier, right? So there's and that is actually the center of gravity of all the different pieces together. Enter. So let me get rid of this one. We don't really need it. It's just a temporary, but if we orbit around this, you'll see that it's off center just a little bit if we're looking at the plan. And then if we're looking at the side, like that, you can see that it's below the main horizontal piece. So what the best way to do this, I say, is, since those calculations get really complicated, the one that's hard is getting the diagonal length right here, because you're at elevation, so you have to calculate the elevation. Above this point, you have to calculate the elevation of the first CG, then the second CG, and then you know the distance between, away from the in height, and then but you have to do the first one, and then it's just complicated. So I'm going to show you how to do it. There's a reason. So this will just use this to confirm that we're doing it correctly. Okay. So let's go back to 2D. Actually, control 3D. I want to take a snapshot of that. All right, tool close, edit, section copy. It doesn't work like that. Image. And then that'll work. And then I can go to 2D, Control V. There, we can just use that to check our numbers, right? So here's the actual 2D isometric, okay? So what we're going to do to make it simpler is we're just going to look at the plan view right here. Top view. Yeah, it's Control W. We'll see this one. So we're going to make a top view like this. So it actually look pretty similar. And then a side view, which would look like this up here. No. Yeah, so this is side view. What is that? That's the 11? No. Here, like this. So one's going to look like this, the top view, and one's going to look like that. Maybe from the other side, because we're working on the isometric from the other side. All right, so let's go to 2D. So we're going to go 4.5 V, point relative, -4.5, enter. And then point relative tab, -23.67. Actually, let's go 66667, enter. Enter, and that's what it's going to look like from the top. Make it gray. And then here we're going to have this piece that that we're going to be looking down on it, right? So it's a vertical view, overhead view, 4.5, then the 23.67. And this is looking straight down this piece, so you don't see it, but it is 11.75. Enter. And what happens is if this vertical piece here was to be connected to, let's say, the middle, okay, like this, Control, the elevation of the center of gravity, the height of it would change, but since it's in line, it would not change the location of the point and plan view, even though the height might change, right? So we can do this. Now what we're going to do is 11.75 is 0. We're going to find the distance to the center. Control K. So the distance to there is 11.83. And we're going to take 11.83 tools, calculator, 11.83 times, the weight is 23.67 divided by, it's the same calculation, 11.75 plus 23.67, close parenthesis, enter. And I didn't copy the formula, but it's the same formula. $11.83 times 23.67 divided by, open parenthesis, 11.75 plus 23.67, close parenthesis, equal, there you go. All right, and then now we know, let's change this to red. V relative tab 7.9056, enter. Enter, and that's the red part. So that's the vertical. If we look at the other one, it would be, so let's say, I'm going to take that, 7.9056, and then look at the 3D, just to show you what this is. We're looking at this red line in a plan view. So in here, it was 8 something, right? Oh. .83, but in the elevation view, 7.90, right? 7.91. Right? Control R. So that's what we're doing, is we're looking at plan view. All right. So now I'm gonna know, I know the center of those two, so V. I'm gonna look at the, change it to the green, and then change the line type to that, and then Control K. So now I need to know along this line where the plan view of it is, right? So using the Pythagorean theorem, I can go 2.5 over the remainder of this, right? 15.76. So 2267 minus 7.91. Now I have the rise and the run. I can calculate that diagonal. You know, if you want, tools, calculator, square root of 15.76 squared plus 2.25 squared, close parenthesis. So we'll see, Control V equals, and Control C, Control V, right, 15.9, that's this one here. All right, now we're going to do the same thing, 15.92, 15 times 4.5 divided by, open parenthesis, 11.75 plus 23.67 plus 4.5, close parenthesis. All right, and then we have the length of along this line. So V, same as JD, 1.7946, enter, and that is it. All right, so now we have this one. And then the plan view, that's the center. So let's draw the point mark. And we don't really, we know the location along that line, but it hasn't really given us this. So to calculate this, we need this dimension, right? We need to know that it's 3 inches away. So the way you find that, and we're going to need to know this one. Uh, 1.78. So that we can figure out, so we had the 7.9 to win, we could add that and we'll know for the distance from this pipe, center of this one to this one, right? So we have to calculate these two numbers right here. So to do that, I'm going to just use some scribble. I'm going to go 2.25 is equal to, so the rise over the diagonal, 15.92. And that would be the same ratio as, you could use trig to do this, but I'm just going to do this because I can't. So it would be the same as the x, the rise here, this is the run, the rise here is to the run, as to the diagonal, I mean. The 2.25 to the diagonal, x, which is the unknown, to the diagonal. We already know that the diagonal was 1.7946 right here. All right, so scribble. All right. All right, so then we just, I'll do this one real quick, the calculator. So it'll be 1.7946. We got to solve for x. 1.7946 times, open parenthesis, 2.25 divided by 15.92, close parenthesis. All right, so there's our 0.25. And then the other one is pretty much the same way. So we could do it, the run here, we said 15.76. I don't know why I deleted, but I did. So we could go, scratch it out, 2.25 is to the diagonal, or sorry, no, it wouldn't be 2.25, it would be this. 15.76 is to x as, no, 15.76 as to, we already do know that this is to the diagonal, right? 15.92. I think. So this, the run is to the diagonal, as the run is to the diagonal. We know the diagonal is this, so it'd be x, the run, which is unknown, is to 1.79. 46. So we'll do the same thing. Got 1.7946 times, we'll solve for 8x, we get times 15.76 divided by 15.92. 0.7946 times 15.76 divided by 15.92. go right down there and add that, Control V. And that should be 1.776, 1.777. 1.77, it's just rounding up. Right. So that's how you get that. And then you could just add that, the 1.77 to the 11.83. And then you have, let's go purple and we'll just do the same thing here, right? The total distance, Y, 9.68, and the distance away, 0.25. So there's all your calculations. All right, so now you've got it in the plan view, and you would do exactly the same thing on the side view to find out where it is relative to the elevation. However, if this isn't going to rotate, you don't really need it. You know that if you connect it with 2 points, it is going to be pretty stable. You'd have to have it somewhere along this point, right? So let me just draw purple, V. So you could go K, here, B, and we'll just trim that up to here. Oh, I don't think I did that right. That's better. Oh, what's it grabbing to there? I don't know. So you could actually go right along those 2 points here, right, to measure that, and you would be able to pick it with 2 points. It'd be pretty stable. You could swing it right, you know, clockwise or counterclockwise with one hand. If you're not, if you got, so the limitation there is sling length, right? You have to have exactly the right sling lengths, and then they've got to stretch it to the same rate, and then you got to have, yeah, it's going to be hard to make those match because they're going to be kind of arbitrary. As long as the hook is above this point, it'll be good. So probably what you want to do is run a 2 slings. Let's say this was 9.68. There's, as long as this is off 3 inches that way, or 0.25 feet. But if you had your slings along this H, V, K, H. Okay, so as long as these sling lengths match to meet in the middle. Let's say you have a 10-footer, and then you have a 12-foot. Let's see, I don't know what those are not. Let's go here in the 3D view and actually use some sort of truth to the numbers, right? That's our isometric view, right? This is our plan view. And then I want to rotate. So it's long V, H, K, enter. So say right here you have a V, K, H. You got it's kind of long. Let's go. Oh, no, it's not long. Say it's a 20-foot even, right? selection handle that. Yeah, like obviously if it was a 20-foot sling, there'd be some variation, right? And I gotta move this over. Then this one here, just you'd slide it if you want to get it pretty close. V, let's say you were starting there, K, H, enter. It would be 19. So let's go like this. Let's go say we had a 17-foot 9 sling, right? That's how you would do it. You would swing it till it matched, and it would actually still lift it here. You'd be picking up a lot more load on that sling, but that's how you match it up, right? And then these two slings can actually not be customized, right? And then with the 3 inches off center, you could just use a small chain fall to go from here to here, enter, right? And that would be pretty much it. And I think that'll do it. That's pretty much how you do it in 3D. If you need the elevation, let's say this was going to rotate, then you need this elevation here, this the height of that point, because then what you kind of end up doing is running a sling across here. Let's say you did these two slings. The nice thing is these two slings will still work, so you can match up the slings. So if you go arc like this from that center to there, I think I lost it. Arc from there to there, right? V, H, enter, and then we just trim those like that. Like that we can come from Control R. So now these two slings are going to be used to go up here. They're going to be in line with this. I think I'm getting maybe a little far out, but you'd use two similar slings. They would be in line with the center when they were, from basically connecting them at the same point, just to the right of each or just to the left of each. They're going to be basically the same way. They're hanging so that they end up going like this. All right, so let me get rid of this. And then get rid of that. And then they're just so that when you need both. You need these, lift it up, and then what happened is you'll loosen this one up while these are starting to lift up. If I would do it, I would do it the other way. I would lift it from the other way, because then this sling would get shorter, right? So Control H, like that, delete. So that as you're lifting, as you're taking the load, and then what would happen was this would have another sling right here, V, like that, enter. So then as you're this is slack on the, so this is slack hanging there like this. Right, this one's going up to the main, or vice versa, and this is your whip line. And you lift it up. As you lift it up with this, it's going to hang freely, right? And then as you take up the slack out of your whip line, it'll rotate up. Let's see if we can get this whole thing to just, let me get rid of these dimensions here. Close. Let's go. Tools. Edit. Selection filter. Dimension. Entity type. Put those on layer 2, and then go to layer, hide layer 2. Okay. So then we can go like this, right? H. Close. So yeah, you'd be lifting it up like this, and then as these two lines, this line will get slack as this one goes up. It'll start rotating until these two, let's just do it, Control H. Rotate along the z-axis. -30, enter. Yeah, and then this would start, I don't know what happened. Yeah, this has to rotate too. Control H. Rotate -30. Right, so what's happening is that's happening, this is getting slacker. Okay. And this one's getting tighter. This one's actually tight now. And they're both taking the load until this one's taking all the load, and then that one has 0. That's how you would rotate it up. And then if we went take it all and this, yeah, Control H, rotate 60, Control H, rotate -60. Right, now we have all the load on this one. And then this one's getting the slack now. Right, that's how you would do it. But you need to know the height of the thing so that when this is vertical, you're above this, right? So it would just be, this thing would be going straight down into that center of gravity there. If it was plumb, I don't know that it is, yeah. That's how you would do it. That's about all I can tell you. All of it in rigging up like a steam pipe that has 3 axes going different directions, and having to pick it in position with just three slings, mostly with the 2. You could do it with 2, but it's much easier to do with 3. So if it's no problem, if you hadn't have the headroom or you couldn't use it out there, you could still pick it with 2 and something like this. Almost if you just choked it so that the choke slings were on the edge, but you know you can't do that because it's dangerous, right? You can't sling back, choke more than, you can't, what do they call it, choke back. You can't have that choke back and like that. So you just need to throw an extra little chain fall or something, an adjustable sling or a turnbuckle on the back leg right there to plumb it, to level it out. It would be pretty level, but it wouldn't, be 3 inches off. You'd be probably hanging at 15 degrees or 10 degrees. So hope that helps you understand and pick that type of pick. And I know I went a little overboard. I don't think you guys are picking that and rotating it, but if you did, you need to do a little bit more involved. And at some point, maybe I'll make this more clear, but I hope that helps you get the job in, and hope it helps you in your career and helps you train somebody else so that they know how to do it. Thanks for watching. Have a great day. Wow.